Spotlight, the PitchAbility 2025 winner, XR Navigation. Speaker, Brandon Biggs, CEO of XR Navigation.
Hello, my name is Brandon Biggs, and I am the CEO of XR Navigation, a PhD candidate at the Georgia Institute of Technology, and an engineer at the Smith-Cadwell Eye Research Institute. Today we're going to be talking about Audiom, the first digital map and spatial diagram tool everyone can use. I want you to close your eyes and imagine. You smell the smoke and pull up the wildfire evacuation map and hear
clickable show street map radio menu item check submenu out of menu bar map clickable blank blank blank.
If you're blind, this map is blank. Open your eyes. When I say the word map, there are two types of maps that I'm talking about. There are referential maps where the objects on the map are the most important. These would be maps such as transit maps, park maps, and trail maps. Then there are thematic maps, where there's some kind of numeric or categorical variable overlaid on top of the geographic map. These would be maps such as COVID statistic maps, election result maps, or weather maps. Both of these are what I mean when I say the word map. In April 2026, the Americans with Disabilities Act Title II regulations go into effect, which means the Web Content Accessibility Guidelines will now be the required compliance for state and local government entities. This means that every state and local government in the United States needs to make their digital content accessible by April. The Department of Justice has explicitly said that geographic maps need to be accessible. These Web Content Accessibility Guidelines are 76 criteria that can be used to systematically evaluate digital content for accessibility. A recent report was published looking at the level of accessibility for the top digital map tools, and they found that none of them even met the most basic level of accessibility. The experience is what I showed before. For blind people in particular, they are completely blank. But blind people are not the only ones who have issues and barriers accessing geographic maps. People with mobility impairments, keyboard-only users, low vision users, and people who are illiterate are unable to use geographic maps in their current form. Oftentimes, when people think about an accessible map, they think about a tactile map for blind people. These are great if you can get a hold of them and you know how to read them. The problem is these are not digital, so they do not comply with the Web Content Accessibility Guidelines. Oftentimes, what people are doing now to make their maps accessible is have contact information on the map that says, if you have any questions about this map or have any accessibility issues, please reach out and call us. These are also not compliant with the Web Content Accessibility Guidelines. Traditionally, geographic maps have been made accessible using turn-by-turn directions, a list of objects on the map or a nearby address search, tables, or simple alternate text. The problem is that these types of alternate text completely remove the spatial information that makes something like a map. This is distance, direction, shape, size, orientation, topological relationships, such as the bordering objects and how they intersect with each other, and none of this information is communicated on the traditional methods of alternate text. So that's why we created Audiom. It's the first digital map and spatial diagram tool everyone can use. The visual experience of Audiom allows you to zoom in up to 200% without squashing interface elements, adjust the border width of features to make them easier to see, switch between using patterns and colors for somebody who's colorblind, click on different features to have them read out to you in text-to-speech, and really customize the interface to be how you want it to be. The non-visual version of Audiom is like a video game, or an audio game for those who know what I'm talking about. You use your arrow keys, touchscreen, or other controller to move a character around the map a user-specified distance. Here's an example.
First tier section in Nixon Hall. First ramp, trash cans along with ramp. Second row table, west in Nixon Hall.
Using these conventions, somebody who's totally blind can access all that spatial information that I mentioned earlier, such as shape, size, orientation, distance, and direction of all the objects on the map. Our clients include the University of Washington, Wisconsin Geological Survey, and NASA. The digital spatial diagram market is $102 billion, and none of these are usable. I want you to raise your hand if you have seen a digital map in the last week. These would be Google Maps, weather maps, gerrymandered maps. Able-bodied people view 300 maps a year. Contrast that with blind people who view less than one. This massive gap is personal for us. Both my co-founder Chris and I are blind. My co-founder and CTO Chris has built some of the most influential apps in the blindness community, including Chicken Nugget, NVDA Remote, and an app allowing blind people to independently solve CAPTCHAs. I am finishing my PhD at Georgia Tech researching non-visual digital maps with Audiom. This is an example of an Audiom indoor experience. This is a demo of the multi-level Audiom building experience at the New Orleans Marriott. I'm currently at the Canal Street entrance and I want to go to the Grand Ballroom. The first thing I'm going to do is open up a list of all the objects on this map by pressing the M key for menu.
M. Filter objects submenu 2 of 202.
And I'm going to use Control F to find Grand Ballroom.
Control F. Find edit selected Grand. Enter. Result 2 of 3. Grand Ballroom, Acadia Ballroom, 3rd floor, room, is 13.
And it tells me it's on the 3rd floor. So I'm going to escape out of this.
Escape. Audiom map.
And open up the menu of only the objects on this floor by pressing Shift M.
Filter objects submenu 2 of 42.
And find an elevator.
E. Elevator, 1st floor.
And get directions to it.
Go 2 of 6.
I hit enter.
D. Directions submenu 5 of 6. Enter. Elevator, 1st floor, is 13 steps left and 7 steps up.
And now I'm going to use my arrow keys to move around the map. Every arrow press moves me 1 meter by default, and I can change that by pressing the dash and the equals key. I'm going to go left first.
Left arrow, Canal Street entrance exit, 1st floor, left arrow, bumped into wall.
So I hit the wall, and I'm going to go up.
Up arrow, walkway, 1st floor, left arrow, walkway, left arrow, walkway, left arrow, bumped into wall.
And I'm going to use a trailing technique similar to what I would do with my cane to see if I can continue up and to the left.
Up arrow, walkway, left arrow, bumped into wall. Up arrow, walkway, left arrow, bumped into wall. Up arrow, walkway, left arrow, walkway, left arrow, walkway, left arrow, quarter tower elevator lobby.
And I'm going to hit the D key to see where the elevator is now.
D, elevator, 1st floor, is 3 steps up. Up arrow, bumped into wall, 1st, left arrow, door. Up arrow, elevator, 1st floor.
And I'm going to use the levels menu by pressing L.
L, 1st floor lobby radio button checked 1 of 3.
To get to the 3rd floor.
Down arrow, 2nd floor radio button checked, down arrow, 3rd floor, enter, application.
And that switched all the features to the 3rd floor. So I'm going to press the Shift M key to open up all the objects on this current floor.
Filter objects submenu 2 of 41.
I'm going to find the Grand Ballroom.
G, Grand Ballroom. Go 2 of 6.
And get directions.
D, directions. Enter, Grand Ballroom, Acadia Ballroom, 3rd floor, room, is 2 steps up.
And if I go up,
up arrow, bumped into wall.
there's a wall. So I'm going to go down.
Down arrow, quarter tower elevator lobby.
And I'm in the elevator lobby. So I'm going to go left.
Left arrow, quarter tower left left arrow, Acadia Ballroom foyer, third,
And I'm going to go up.
up arrow, Acadia Ball, up arrow, bumped into wall, left arrow, Acadia Ballroom foyer, up arrow, Acadia Ball, up arrow, Grand Ballroom,
And we made it to the Grand Ballroom. Indoor maps are used for work, recreation, and navigation. If you are booking a seat for a football game, you need a map to select which seat you want to sit at. If you are in a hotel, every single door in that hotel has a map that shows how you evacuate from the hotel in case of an emergency. These are so inaccessible that I didn't even know they existed until someone told me. When I touched them, they were completely blank. Indoor maps are everywhere, and they're super, super important. I want to tell you about one of our clients, the Vision Rehabilitation and Assistive Technology Conference, VRATE. They had an all-blind planning committee for their conference. And before working with us, the map they had was blank. It was a PDF that was completely inaccessible. So they had to depend on their contractors and the venue to plan out their exhibit hall. But when they worked with us, we gave them an Audiom map before the conference began that allowed them to preview and approve the exhibit hall layout for the first time. When the conference began, they made this map available to everyone who attended the conference, and over 2,000 people used the map. This is an Audiom campus map for outdoor types of maps, such as neighborhoods or parks. This is a non-visual version of an Audiom campus map. We're currently at the Visitor Center, and we want to go to the Flight Project Center. I'm going to open a list of all the actions you can do in Audiom that's first letter navigable by pressing F2.
open main menu, enter, G, get, G, go to dialog, enter, go to dialog object, clickable, search property page objects combo box collapsed has, enter, search property page, F, A, T, down arrow, JPL building 321, Flight Project Center, enter, toolbar, go button, down arrow, listen button, down arrow, description button, down arrow, directions button, enter, JPL building 321, Flight Project Center, building, is 333.9 meters ahead and to the right.
So we can tell it's quite a distance away ahead and to the right. I'm going to escape out of this dialog.
Escape.
And turn on a radar.
R, radar enabled.
That will beep in the direction that we need to go and get faster as we get closer. Now I'm going to use my arrow keys to move around the map. Every arrow press will move me 4 meters in that direction, and that's because I have my step size set to 4 meters. I can have it set to whatever I want it to be.
Right arrow, JPL building 249, Visitors Center, building 301.
And what we heard there was the name of the object that we're on, Visitor Center, the type of the object, building, and some coordinates that tell us where we are on the map, along with a short sound representing the Visitor Center.
Right arrow, empty space, 3.
Empty space just means that there's no data for this location, which is pretty typical for maps. There's a lot of empty space on maps.
Right arrow.
Now I hear a building to our right, and I'm going to go investigate it.
Right arrow, JPL building 339, Cuisine Cafe.
Cool, there's a cafe to the right of the Visitor Center. Now I'm going to open the Nearby Objects menu and see if there's a road that we can follow to the Flight Project Center. I'm going to press F2.
Open main menu. R, Nearby Objects menu, filter objects 1 of 9. Down arrow, JPL building 300, down arrow, JPL building, down arrow, Mariner Road, 35.6 meters ahead and to the right.
So the road is ahead of us and to the right. I'm going to close out of this menu.
Escape, application.
And go find the road and follow it.
Up arrow, empty, up arrow, Mariner Road, 320, right arrow, Mariner Road, right arrow.
Now, I hear something behind us, and so I'm going to go investigate and see what that is.
Down arrow, JPL building 301, project formulation.
Cool, so project formulation is in between the Visitor Center and the Flight Project Center. I'm going to return to the road and continue.
Up arrow, Mariner Road, right arrow.
Alright, and we finished the road, but I hear that we're super close to our destination. So I'm going to continue.
Right R, right arrow, JPL Building 321, Flight Projects Center.
And we've made it! Outdoor maps are typically what we think of when we think of a geographic map. They are used for campuses, navigation, and city planning. They also are used for allowing civic participation for infrastructure projects. In my city of Atlanta, Georgia, the transit agency recently published a complete redesign of the bus routes around this city. And they asked for public feedback. Being someone that completely relies on public transit to get around, I, of course, opened up the survey to give my feedback. But the very first item on that survey was a map that was completely blank. And every single question required the use of this map. So despite being someone who requires public transit and depends completely on public transit, because I can't drive, to get around, I was unable to provide my feedback. So the city didn't hear from the people who used the transit the most. And this is happening all around the world, in particular in the US, because that's what we're talking about. The communities that are dependent and rely on the infrastructure are not being heard. I want to share one other type of geographic map, a thematic map. And this is a COVID statistic map. The visual version of Audiom allows users to switch between using colors and pattern, adjust the border width of features, zoom in up to 200% without squashing interface elements, and customize the interface to be how they want it to be. The non-visual version of Audiom has two modes, a tabular view and a geographic view. The tabular view
Table
has a row for each of the features on the map and a column for each of the properties associated with those features. We find a feature of interest.
Down arrow, Montana row header row 2 name column. Down arrow, Alaska row header down arrow, North Dakota row header.
And a column of interest.
Right arrow, 292,604 North Dakota row 4 total cases column 2. Right arrow, 383,964 North Dakota row 4 cases per 1 million.
And what we heard there was a pitch that's relative to the other pitches in the column, so we can tell that North Dakota has a higher number of cases per 1 million than the other rows. Now I'm going to press enter,
Alert maps.
and that jumped me to the center of North Dakota and switched the statistic on the map to cases per 1 million. Now I'm going to use my arrow keys to move around the map, 50 kilometers each arrow press, and I'm going to use a technique called weaving to explore the border of North Dakota.
Right arrow, North Dakota, 383,964 cases per 1 million. Right arrow, North Dakota, right arrow, Minnesota, 322,284 cases. Down arrow, Minnesota, left arrow, down arrow, South Dakota, 319,779 cases per left arrow, South Dakota, up, left, down, left, up, left, down, left, up, left, down, left arrow, Montana, 312,280 cases, up, right, up, left, up, right, up arrow, empty space, right arrow, empty, down, right, up, right, down, right, up, down, right, up, down, right arrow, up, right, down arrow, left arrow, down, right, down, left arrow, down arrow, south.
And what we got there was the shape, orientation, and size of North Dakota, and the distance, direction, orientation, and general layout of all the features bordering North Dakota. We also learned that Minnesota has the highest number of cases per 1 million bordering North Dakota, but North Dakota has the highest number of cases per 1 million out of all the features we explored. Thematic maps are used for work, data analytics, and politics. If you work in a profession or want to work in a profession such as oceanography, meteorology, epidemiology, or city planning, you need to view thematic maps. Currently, blind people aren't really represented in these professions because it is extremely difficult to get these types of maps in education or even if you are a professional. This needs to change. I want to tell you a story about one of our clients, Caroline from the Wisconsin Geological Survey. After 13 years of being a professional cartographer, she attended a conference in 2023 where she learned that the maps she'd been creating her entire professional career were useless to 20% of the population. She learned that the only way that she could make her maps accessible and compliant to the Americans with Disabilities Act, Title II regulations, is to provide a detailed text description of every single object on the map. The problem is that her maps had over 3,000 features on them. So creating a detailed text description would be longer than a Harry Potter book. She reached out to her local National ADA Center, and they put her in contact with me because she wanted to know if there was any better way to make her maps accessible. And now we are getting ready to publish the most advanced accessible digital map in history. In the last year, we have had over 25,000 unique users. We received a $2 million grant from the National Institutes of Health. We signed a distribution partnership with the Canadian National Institute for the Blind, and we received an accessibility report showing we are the only legal map viewer on the market. Our vision is that all maps are usable to everyone. But we need your help. When I talk to city, state, or local government entities, they say, "You're the first person to have ever asked us for an accessible map, so it must not be important." So we need to tell them that it's important. I want you to open a web browser and enter in this link, audiom.net/email. That's audio, M as in map, .net/email. And this will pull up a template that you can send to anyone to request an accessible digital map. We also have contact information for state, local government, or other types of entities that publish geographic maps. And I want you to send an email to at least 3 people to ask them to make their maps accessible. If you have any questions, please reach out. Our email is also on that contact page, but we really need you to help us. Allow 1 out of every 5 people to use a map for the first time. Thank you.